An AI agent perceives its environment, reasons about actions, and takes steps accordingly. Different agents vary in perception, memory, planning, and collaboration capabilities. This series covers 6 types: Reflex, tool use, planning, memory-augmented, multi-agent, and autonomous. They range from simple and predictable to complex and capable, handling long-term tasks but requiring careful design. Each episode includes a detailed diagram explaining data flow and can be watched in any order based on your needs. A reflex agent is the simplest type of intelligent agent, perceiving its environment and immediately responding through a set of condition-action rules. It lacks memory or forward planning, making it fully observable and deterministic. Reflex agents work well for tasks like controlling thermostats or spam filters, but they struggle with situations requiring historical context or adapting to new conditions. Beyond a single prompt, an LMN can't interact with the real world, but tool use agents can. They follow the React pattern, which involves reasoning and acting. In each iteration, the model produces a thought, chooses a tool, observes the result, and decides the next step until the task is complete. These agents can search the web, execute code, read and write files, call APIs, and query databases, making them powerful execution engines. For this to work smoothly, tool calls must be explicit and machine-readable to ensure reliable parsing, dispatching, and returning of results. This pattern is ideal for research tasks, coding assistance, data analysis, and workflows with multiple steps and external dependencies. React agents excel at simple tasks, but struggle with complex multi-stage work, often leading to redundant actions and dead ends. Planning agents tackle this by separating planning and execution. The planner creates a structured plan with an ordered list of subtasks, while the executor focuses on reliable execution. This allows for parallelization, retries, and specialization. However, rigid plans can fail if the environment changes. Smart planning agents check intermediate results and replan if needed, adding robustness. Planning agents are ideal for complex tasks like document generation and software projects, where completing prerequisites in the right order is crucial. The context window problem in LMS limits how much information can be handled, especially in multi-turn interactions or large data sets. Memory systems address this by storing and retrieving information as needed. Working memory holds current conversation and tool outputs, while long-term memory stores past interactions and learned facts. When a new query comes in, it's embedded and searched against a vector store for relevant information, which is then added to the context window. Useful facts from these interactions can be saved in long-term memory, making the agent more knowledgeable over time. However, more memory increases accuracy but also retrieval latency and cost, so strategies like recency weighting and importance scoring are used to manage the memory efficiently. A single generalist agent must switch contexts between various tasks, leading to inefficiency and errors. Multi-agent systems improve this by assigning each task to a specialist and coordinating them through an orchestrator. The orchestrator takes the main goal, breaks it into tasks, assigns them to specialists, and combines their results. These sub-agents operate independently and in parallel, reducing latency. Each agent is equipped with tools specific to its role, enhancing output quality. Agents communicate via structured messages, ensuring the system is composable and easier to debug. However, multi-agent systems can amplify errors, so designs include a critic agent and explicit validation steps to prevent cascading failures. An autonomous agent is given a goal and left to pursue it independently, deciding on tools, replanning, handling failures, and assessing goal achievement on its own. In each iteration, the agent observes the environment, reasons about its state relative to the goal, decides on the next action, and executes it, repeating until a termination condition is met. Strong agents also include a reflection step to evaluate and adjust their plan if necessary. Autonomous agents must manage their own resources and have safeguards to prevent issues. Fully autonomous agents represent the current frontier of AI deployment, enabling long-running processes with the challenge being to ensure safety and reliability.